Says the practice circuits handout. If you got the hang of this, great. You can just follow along, but I know that a lot of people were asking me about some of these, so let's walk through this. This is going to be our little study tutorial review. Unfortunately, I don't have time to do a tutorial for you guys. I apologize, but we're doing it in class. So, first thing that I always do was I label which way is downhill. So downhill is that way. So, by the way, just as a good multiple choice question, which way does the current leave the battery? To the left or to the right? In this particular circuit here. Which way is the current going from the battery? To the left or to the right? To the left. Which way do electrons flow? To the right, but we've decided for current we want to talk about positives because it's just so much easier to think that way. And remember, this is the positive, this is the negative. There is going to be a matching section where I give you several circuit symbols and I say, tell me what's what. So what is this a symbol for? What's the symbol for a switch? Open switch. Closed switch. Battery. Light bulb, I think we'll come across anyways, but okay, so I would label downhill. Then I said I always look for total current. What I really mean by that is, and my analogy was current was like the number of skiers on the ski hill. I go to the chairlift, the battery, because we said the battery was like a chairlift, and I want to see if I can figure out how many amps are leaving the battery. And it turns out, you know what? I know how many amps are leaving the battery. This right here is the total current. You don't have to write that, but I'm just going to make a little note of that. Brady, when the current gets right here, it's going to split up. If the resistors were identical, you'll learn in Physics 12 as a shortcut I teach my students, if this was a 12 ohm and another 12 ohm, the current splits up 50-50. Are these resistors identical? Duh. Okay. Well, let's keep going. I don't know how many amps went this way. I don't know how many amps went this way. But then they recombined right here. When they recombined right here, how many amps do I have right here? Why such a weird number? Because I was using an actual circuit. I had to make the numbers work. 2.985. So right now, here, I have 2.985 amps. And now I go ding, 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 because I know two things. Then I know all four. I get my trusty calculator out. How can I find the voltage in that 10 ohm resistor right there? I times R. You know what? I don't need a calculator. I'm multiplying by 10. I think the voltage is going to be 29.85. Now, I didn't ask this, but how can I tell how many watts of power is in that resistor right there? Because this would be another way to give you the same diagram and just find something different. How many watts in R2? How can I figure it out? V times I would work. Or I could have actually gone I squared R, and I didn't even need to, if they had just said find the power, I could have quit. V times I, so it's going to be 29.85 times 2.985. That's a 89 watt bulb, 89.1 watts of power. Keep going, keep going, keep going. In R1, in that resistor up top, what else do I know? I know it's 12 ohms. What else do I know? Current. What's the current, Hannah? Yeah. This is the current rule. Current doesn't vanish. It splits up, recombines, splits up, recombines. But yeah, if I know that there's no junctions, then all of the current flows through it. 2.985. Why is that nice? Because I can also find the voltage. It's going to be I 2.985 times R 12. The voltage is 35.82 volts. And now, Josh, I've come back to the chairlift. I think I've tried to find everything I can. Now I go to my third step. My third step was anywhere where I know two things, I know three things. I kind of did that simultaneously with following the current. The fourth step was we go skiing. And what I really mean by that is we're going to go in a closed loop. Here's a closed loop. If I start here, Does that get me to the bottom of the chairlift? How many volts high is my battery? 80. So how many volts must I lose going through that closed loop? 80. I have to. By the way, there's another path I could have gone. I also could have gone that way. The reason that I didn't care about that, Brian, is this question wants me to find the wattage, the power in that one. So I said, why don't I go through that one? Maybe that might help. Is that okay, Brian? Okay. Brian, how many volts here? How many volts do I lose going through this one? I don't know. How many volts do I lose going through this one? How many volts do I lose going through this one? Okay, so I think I can go like this. 80 minus 29.85 minus 35.82. You know what? This has to be 14.33 volts. Has to be. Why does that help? Because now I can find the current. Current is V over R. It's going to be 14.33 divided by 8. The current is going to be 1.79125. I'm going to write 1.79 amps. How can I find the power? Power is V times I. You know what? I'm going to be really clever. I'm going to use my answer button, which has the 1.79125, just to be really, really accurate. How many watts of power? 25.7 watts. Is that okay? Let's try the next one. Labeled downhill, I already did that. Did they tell me how many amps are leaving the battery? No. Maybe I can figure it out. Do I know how many amps in here? No. Do I know how many amps in here? No. Do I know how many amps in here? No. Yeah. But that was step 2. Try and find current. Step 3 was anything that has 2 things, I go tackle that right here. I know 9.2 watts. I know 33 ohms. What else can I find? This one is really tricky. This one is harder than you're going to get on your test. Unless I gave this to you. Did I give this to you on the purple sheet? Did I give you an equation that got... Did I give you that on your purple sheet? I didn't. Okay. I shouldn't have given you this one on your review. Anyways, I know that power equals I squared R. What that means, Franz, is I squared equals power divided by R. In other words, if 15 equals 5 times 3, 5 equals 15 divided by 3. Do you guys know, you guys learned this, I think, in Math 8 or Math 9. I think you learned it this year. What's the opposite of squaring something? Brady. Turns out that's a new equation as well. You're not going to need that one for the test. But if I go on my calculator, 9.2 power divided by 33, and then I square root that, square root, and I'm going to go answer button, I get a current of 0.528 amps. And now the question's going to fall apart. Say what? It's going to fall apart. How do you know? Well, how many volts are there here? 0.52 I times, oh, not 0.33, Mr. Duick. I times R, 17.424 volts. Why does that help? Ski. Is that a ski run? Does that get me to the bottom? Yep. Mandy, how many volts high is this battery? How many volts do I lose going down through this resistor? 17.424. This is the last resistor, gets me to the bottom. You know what? This has to be 24 minus 17.424. It has to be 6.576 volts. It has to be, let me erase this now, 6.576 volts. Is that what I said? 6.576? Yeah. Why does that help? Well, Hannah, now I know two. I know all four. Current is going to be 6.57 V divided by R. I could have done that one in my head. 0.6576. Amps. And Evan, this one is really nice because it seems to me that this current, it's actually the total current, because if I look, this leads directly to the chairlift with no junctions. So how many amps are flowing through this circuit grand total? How about 0.6576 as a decimal there? That's okay. Say it again. 0.6576. One more time. 0.6576. How many amps went this way? 0.528. How many amps must have gone this way? 0.6576 minus 0.528. You know what? 0.1296 amps must have gone that way. Oh, also, Ibrahim, I can fill in power from your purple sheet. Power equals what times what? V, there it is, times I. So the power in that top bulb is going to be 6.576 times 0.6576, V times I. That's going to be a 4.32 watt bulb. Mr. Dewick, what do we round off to? Well, 2 or 3 decimal places is usually pretty good, unless it ends, but this is, I'm not going to be that accurate. Oh. Hey. Josh, we can ski that way too. See it? Josh, how many volts high is the chairlift? 24. Do I know how many volts I lose going through this resistor? Say no. Do I know how many volts I lose going through this resistor? I do now. How many? So I think I can figure out how many volts I must lose through this resistor. I think it's going to be 24 minus 6.576, right? Because it's got to get back down to 0. And someone wanted to say, Mr. Dewick, couldn't I have also noticed that these two are in parallel and will have the same voltage? Yeah, because I got the same answer. As a shortcut, you might have noticed, hey, I can move that voltage right to there. And if you did, great. You're really wrapping your brain around some of the tricks of the trade, Danielle, some of the shortcuts you can take. But you'll notice you didn't really need that shortcut. It's just a shortcut. It's not essential. 17.424. Do I know 2 things? I know 3 things. I can now tell you the voltage, the power. 17.424 times 0.1296. How many watts? 2.26 watts. What's the resistance? R equals V over or divided by R. V divided by I. I said R, didn't I? It's 134 ohm resistor. Couple of little things to notice for what it's worth. Which resistor is bigger? This one, the one in the middle, or the one on the right? Which resistor is bigger? This one? When you have a bigger resistance, what happens to your current? Goes down. Goes down. Okay. When you have a bigger resistance, what happens to the power? 9.2 watts, 2.26 watts, also goes down. Less current. Okay. You want to try this one? I'm doing this because I didn't give you guys an answer key and I haven't made up an answer key. So we'll go for a few more minutes more and then the rest of the class will be yours to catch up and work on homework and study and all. Label downhill. Is that okay, Nick? Yeah. Did they tell me how many amps are leaving the battery? Oh, Nick, did they tell me how many amps are in this resistor here?
Yeah.
How many amps? How many? Tell me. Just read it up. 0.2? 0.2? How many amps right there?
0.2.
How many amps right there?
0.2.
How many amps right here? Did they tell me total current? They did. Not blatantly, but they did. Since I know the total current, trust me, this is going to fall apart. Let's see. Do I know two things here? In fact, I know three things. You know what? I can also figure out the voltage because V equals I times R. It's going to be 0.2 times 10, which I think I can do in my head. 2 volts, yes? Okay. Ski with me, Nick. Ski with me. Ski with me. How many amps right here?
0.2.
How many amps right here still?
0.2.
How many amps went this way?
1.1.
How many amps must have gone this way?
0.1.
Okay. What if this had been 0.3 amps and I had 0.1 this way? How many amps would have gone that way? 0.2, right? So yeah, current splits up and rejoins. That's the rule for current. Voltage doesn't split up and rejoin. Voltage, if you go all the way around, has to add up to the battery. That's the trick with voltage. Anyways, 0.1 you said? I agree. Oh, let's keep skiing. How many amps right here, Nick?
0.2.
Yes, good. I didn't walk you all the way through it. You just saw it. Why did I go down to there? Because do I know two things? I know three things. How many volts? I times R. I think that's going to be 3 volts. Is that right? Did that one in my head. Oh, and I can also do the power. Power equals V times I. It's going to be 3 times 0.2. Is that 0.6 watts of power? Okay. Step 2, fill in the current. Step 2 I think was, I said, look for anywhere you have two things. Nick, do I know two things on here? Say no.
No.
Do I know two things on here? Say no. Only know one thing. Only know one thing. The final step was go skiing. So let's go skiing. This is downhill. Which way do you want me to go? Left or right? Doesn't matter. This way? Does that get me to the bottom? Yeah. How many volts must I have lost? I must have lost 12 volts. So you ready? How many volts?
12.
How many do I lose going through here?
2.
Leaving? Leaving how many? 12. Okay, good. Right? By the way, if you can, for yuckier numbers, use a calculator, but I think this one we can do in our head. So 10 volts left. Keep going, keep going, keep going, keep going. How many volts do I lose going through there? Don't know. But how many volts are left still? Keep going, keep going. How many volts do I lose going through here?
3.
Did that get me to the bottom?
Yeah.
How many volts must I have lost? I heard someone say it.
7.
Must have. Hey, do I know two things? Now I can find all 4 of them. R equals V over I. R is going to be 7 divided by 0.1, which should be 70. Yay. Power equals V times I, which is 0.7 watts. Is that okay? Now, Nick, we could do the same ski trick going through this run here, or we could notice that these two are in parallel, and so this branch and this branch have to add to the same voltage, because if we split up and meet up, we must have lost the same voltage. How many volts did I lose going down this hill?
7.
How many volts am I going to lose going down this hill?
7.
You didn't include that. I know, but I always like that. Because now I know two things. I can tell you the resistance. It's going to be V divided by I. It's going to be, oh, you know what? These two resistors are identical. Same light bulb, or whatever it is. Is that okay? Between number 4, 5, 6, because there's lots here, and I thought I had an answer key, and I guess I don't. Were there any of these that you tried that you went, Mr. Dewick, I have no idea how the heck to get them, that you want me to go over? Now is your chance to ask. Then, don't write this down, just look up. We're going to do a couple more together, but you don't need to copy these out. But don't zone out. Let me zoom in. Okay? Here's a circuit. Right now, we can't solve this circuit, but if I told you this was 4 amps, how many volts? Right? V equals I times R, and 4 amps going through it. How many volts? Without multiplying, since you know this is a 24-volt battery, how many volts must this... What if I hadn't given you that number there? Could you still figure out how many volts it has to be? How many? Sorry, 4? Got to be 4 volts, right? So even I could take away information, we can still figure stuff out. You could have also gone 4 times 1, get the voltage as well. Do we know the voltage? Do we know we could find the power in each of these as well? Because the current is 4. Power would be 16 watts. 4 times 32 watts, 48 watts, right? Okay. A little smaller, Mr. Duke. Here we go. Okay. How many amps go through each of these resistors? Did they tell me amps anywhere? Okay, so that doesn't work. Oh, you know what I should have done first? Downhill, downhill. And I guess that's downhill, that's downhill, that's downhill, that's downhill, that's downhill, that's downhill, that's downhill. So the current is flowing that way. Electrons are flowing the other way. Current is flowing that way. Did they tell me current anywhere, Evan? Say no. Okay, no amps anywhere. Then I said the third step is look for anything with 2 pieces of information. Do any of those resistors have more than 1 number on them? No. So that's not going to work. The final step, we go skiing. Evan, let's go skiing. How high have we just left? Do you want to go the top one, middle one, or bottom one? Did that get us to the bottom? How many volts must we lose going through the middle one? Must. Has to be. Oh, I got a latecomer. Evan, how many volts must be going through this one? How many volts must be going through that one? This is, did you use the parallel shortcut? Or you could have skied each of those runs and gotten the same answer. So the shortcut, can you survive without it? Yep. And it's so in physics, in fact, if you take Physics 12 with me, I don't show them all the shortcuts. I let the kids figure them out on their own, because that's the best shortcut, is one that you know that I didn't teach you, right? But yeah, 24 volts, 24 volts. So you know what would be a cool question is if I'd given you this original circuit and I had just said, that. How many amps in here? How can I figure out current? What's my equation for current? You're right. So in your head, 24 divided by 3, no calculator required, Evan. This has 8 amps. How many amps going through this middle resistor? 12 amps. How many amps going through this top one? How many amps must be leaving the battery? Plus, plus, and plus, because when they all join together, right? 24 plus 12 is 36, plus 8, I think, is it 44 amps. By the way, this would be a pretty nasty circuit. You would not want to touch it. This battery also wouldn't last very long. The more amps, the faster the battery drains. Okay? What else could we throw at you? You know what? I think that's pretty good. So can you get out now the solving circuits homework? This was the one that you had answers for. This is the one that you can hand in either next class or today. If you want it to study from, don't hand it in today. Or you can also use the practice one that I just gave you the last day to study from. But I want to take questions from here. Were there any of these, and I helped a bunch of you with, I think, the last question or something like that. Were there any of these that you wanted me to go over? Now is your chance to ask. Any of these that you were going, Mr. Dewick, I'm looking at these answers. I got no idea how the heck you got them. So this will be due the day of the test. I'll take questions in a second, but put your pencils down.